I will be discussing triangle similarity. The first thing I want to talk about is the symbol for similarity. So it looks like this versus your congruent symbol. The characteristics are, if I have a triangle, I want to make sure that the sides are proportional, which means that I'm not going to see tick marks. I see tick marks when there's a congruent triangle. I'm also going to have corresponding angles that are congruent. So again, just to refresh your memory, a tick mark are those little marks that are on the side that indicates that sides are actually congruent. We will not see that if we're dealing with triangle similarity. So the postulates that I'm going to focus on in this video and theorems are side, 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 which is notated by SSS, angle, angle, which is notated by AA, and side, angle, side, which is notated by SAS. So for example 1, this is what an angle, angle type situation would look like. So I'm showing you 2 different figures and how you would work through it. So for this first figure, I noticed that I have a triangle within a triangle, so it may be easier to take it apart so that you can see it better. If I were to do that, I have CPQ, and I see this symbol that tells me that those lines or those sides are parallel to each other. So I have another larger triangle, which is CAB. So C, the angle C is reflexive. It's congruent to itself. Now, the reason those parallel line symbols are important is because I've just created some angles. Let's just draw out parallel lines so you can probably see it better, that are created by this transversal that's cutting through those parallel lines. What angles did I create? I'm just going to focus on Q and B. I just created what's known as corresponding angles. So that means that if I were to pick up this one triangle that I just drew over to the side and placed it on top of the second triangle, what's going to match up are the angles for C, and Q and B will match up with each other. So I see that I do in fact have 2 angles that are congruent to each other. So I have what's known as angle-angle similarity in this first example. In my second example, I see that angle D is 25 degrees and angle V is 25 degrees. Well, I could go ahead and mark that with the arc marks if I wanted to, or just keep in mind, okay, so one of my angles from each triangle is congruent. I need 2 angles, however. So in my last video, triangle congruence, I discussed vertical angles. So I have a set of vertical angles here. So therefore, I still have angle-angle similarity. And if depends how you look at it, you could also use the parallel line theorem. So I have 2 parallel lines here. You probably didn't see that if you're not visual. And I have this transversal is the one I'm going to focus on. And what's going on is I have alternate interior angles. So this one angle alternates over the transversal and it's inside of the parallel line. So that's why it's interior. So therefore, I could have used that reasoning as well as to why I have angle-angle similarity. In example 2, what I have is I have some sides, but I do see some vertical angles in this first figure. So I want to go ahead and again show that. So I can't just assume that the other angles are corresponding. So it looks like I'm only working with side, angle, side, but let's prove it. If I were to take these triangles apart, I'm going to go with the bottom one first. I have F with a 10, a 5. I have WV. So that's the first triangle. The other one is upside down, but if you needed to draw it upright so that you can match it, that's fine as well. And then F is at the bottom. Well, we know that angle F is reflexive, so it's congruent to itself, but that's all we know as far as angles are concerned. And now what my strategy is to match the smallest number from my first triangle with the smallest number of my second triangle. That's my strategy. So that's what we're going to do, starting with F. So if I had to write out the points, this is how I would start with F, because I know F is going to be in my first position since it's congruent to itself. and then the other side is FG. So FV is 5 and FG is 11. So now let's try it with the second side, because again, we have one angle and we're trying to find the other two sides. So this is one side, but we have to see if it's true for the other side. F, and if I started, this is my first figure, and this is my second. So if I started with my first figure on top, then I'm going to have to start with my first figure on top again. So I already used FV, so let's use FW. So now what I want to do is go to the second figure and try to figure out, well, what goes with FW? If I were to pick it up, rotate it, and place it on top, what would go with it? Well, it has to be FH. Excuse me. So if I'm substituting in for FW, I have 10, and for FH, I have 22. Well, I can just simplify this and see that it's going to be the same number. So if I divided both of these by 2, I'm going to end up right back at this similarity ratio of 5 over 11, or decimal 0.45 rounded to the nearest hundredths. So therefore, I know that this first figure is similar by side angle side. Let's just try the second one. Same thing. You might want to just take it apart. But before you take it apart, I want you to see that we need to know this part of my triangle for the larger triangle. And the way that we could do that algebraically is to use the segment addition postulate, which tells us to just add those two sides, those two segments. 4 plus x is equal to 8. Where did I get that from? There. And that's a plus sign. It looks like an x. So 4 plus something equals 8. And so once you're solving for x, you're just going to subtract 4 on both sides. X is 4. On this other side, they didn't show us, but if we were to add 7 plus 7, then the entire length of that LN would be 14. So if I'm trying to set this up and determine if it's proportionate, I could do the exact same thing. I could just go ahead and take the triangles apart. At least that's what I like to do because I'm visual. And so for this bottom triangle, I have G4L7H. And then for the larger triangle, I have M this time at the top, 8L14. and N. So see, for me, I can see it easier this way. Maybe some of you see it better the other way. So now what I'm going to do is I see that L is my angle that they share, so it's reflexive. I'm going to start with that LG, and I see LG is 4. 4 is my smallest number of that triangle. So I want to go to the other triangle and look for the smallest number, which I see is 8. It also starts with L, but this time it goes towards M. So that's 8. So what's left over is LH over LN. Again, since I started with my first triangle and I started with that on top, I'm going to have to start with the first triangle on top again. And once I substitute that in, I see 7 over 14. If I simplify both of those, what I see is going to be 1/2. And that's just two sides. So my angle had to come from angle L, which is reflexive. So together and in the correct order, it's still that side angle side. And then the last example is example 3, which we've already talked about angle, side, angle, side. So therefore, this one's going to have to be side, 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 but let's prove it. If I'm looking at the first figure, yes, I do see an angle there. So I probably could do side, angle, side here, but we're focusing on side, side, side. And I notice I do have information for all 3 sides. I just have to match up what goes where. So I'm going to use my strategy of taking, well, let's flip it. I want to take the largest number this time. So the largest number in my first figure is 10, and that's going to be CN. And my largest number in my second figure is 30. So that's going to be CA. Notice I'm starting with C because C is reflexive. So it's going to be in the same position. I just have to figure out what order everything else goes in. And again, I said this is 30. So now I can go to the other side and I can go with my middle number if I wanted to, or the smaller. It's with whatever you want to do. We're trying to do side, side, side. So we're going to do all three. It doesn't really matter. So if we did the middle number, that's going to be 9 and 27. Well, what is that? That's going to be CM. Order matters. I started with the first triangle. So now I'm going to put that over the second triangle. I could have flipped it if that's what I wanted to do. All right, so the second one is going to be CB, and that's over 27. Well, this is just two sides. This is one side. This is another side. I need that third side in order to have a side, side, side similarity, which we already know that's what it's going to be. All right, and then so the last side, I have 5, which is the smallest number, and 15, which is the smallest number. So those two match together. And I'm just going to do, this time I have to do 5 over 15. So that's going to be NM over AB. And you're probably wondering, well, wait a minute, how do you know it went in that order? Because you're going to have to rotate this particular, you're going to have to rotate it. So that's how I knew that triangle. This 30 has to end up, sorry. The 30 has to end up on top of the N, which means A is going to have to end up on top of N. So that's why that order does matter. Hope that made sense. That was a lot. That was kind of busy. But yeah, so I already knew it was going to have to rotate. So you have to pay attention to that. So when I simplify everything, I get rid of those zeros, I'm going to end up with 1 over 3. 9 divided by itself is 1. 27 divided by 9 is 3. Or divided by. And then 5 divided by itself is 1, and 15 divided by 5 is 3. So my similarity ratio is 1/3, and I did just prove they are all three sides are similar. They have the same ratio. So side, side, side. This last one, again, I could take it apart, which is what I prefer to do. That's just me. That's a smaller triangle, and then the larger one here. And on the side, you'll notice that you have the entire length of KM, which is 28. So I could just try to find the similarity ratio by, I'll show you that in a minute. Just know what I was saying a few minutes ago, segment addition postulate, 21 plus X is equal to 28, or 28 minus 21 is going to give you 7. And on the opposite side, 20 minus 15 is going to give you 5. And again, if you add it together, it should give you what they told you that it would equal. That's a plus sign. Okay, it looks like an X. All right, here we go. Plus and plus. We're going to do it upright. Now, taking these triangles apart, I am going to see K, 7, 5, CD, 6. And then the larger one is K, 28, 20, 24, and then I see M and L. So I could have also taken into account going from 6 to 24. That's a ratio. So each side is going to be multiplied times 4. That's going to be my similarity ratio. And just test it, and you'll see that the corresponding side is in fact multiplied by 4. So side, side, side would work. I also, though, see that they share that angle A. So technically, I could use both side, 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 and I could use side angle side for this one if I wanted to. And an example similarity ratio, if you just wanted to know, could be triangle KLM is similar to triangle KDC. And again, you would just set up a proportion. You could set it up like this, or I just showed you the other way. You could see what the similarity ratio is and just work that route. All right, hope you got something from the video. Please thumbs up and subscribe. Have an awesome day.